So filters. If I have some signal at the input, an ideal filter should bring down the amplitude of the output to a zero, absolute zero, and what you'd see on the output is a flat line starting from the zero. Basically, you should see nothing if the filter circuit was an ideal one. Now, filter circuits can be built, both ideal and real filter circuits can be built to be selective. That is, and most of the time, the filter circuits are built to be selective based on the frequency of the signal being sent in. In practical terms, what that means is the circuit can be built in a manner so that only a certain types of inputs will be filtered and certain types of filters inputs won't be filtered and they would be passed as they were received at the input. We'll discuss how this happens in a bit. Now, coming back to discussing what filters were, let's take a look at the real filter case. And in a real filter, the amplitude of the input signal of a signal which needs to be filtered isn't really brought down to absolute zero. Instead, that amplitude is reduced to an extremely small amount, and once it has been reduced beyond a certain threshold, it is considered as filtered out. So, in an ideal case, if the signal you want to be filtered is filtered, then you won't see anything on the output, just a flat line at zero. But in a real case, even though the input signal has passed through a filter specifically designed to filter in that input signal, the output would still carry a signal with a pattern similar to the input, a pattern similar to the input, but with an extremely less amplitude. Now, extremely less amplitudes and quite significant reductions are kind of not kind of but they are essentially qualitative terms, and threshold needs to be defined quantitatively so that we can definitely figure out which of these signals, whether these input signals have been actually filtered or not. And for that, people have developed an expression based on the amplitudes of the input and output signal, and upon evaluation of this expression it will yield a value which has the units decibels, and if this value is less than negative 3 decibels, we consider it as the signal to be filtered out. So what actually will happen is, as I said earlier on, in a real filter case, let's suppose this was the earlier amplitude, and let's say there's a threshold. So this is the original, this is the threshold. So this might be the actual amplitude of the final output. I'll call it A, the final output. Now the threshold is defined using the expression given over here and the amplitude of the input signal, and if the amplitude of the final signal is below this threshold, then it's considered as filtered out. When the amplitude is below than this threshold, these small signals of small amplitude won't really affect any other downstream signal, and that's why people consider them as being filtered out even though they are present within the circuit. Well, that's kind of the mathematical modeling or the mathematical definition behind what filtering out means. And I won't go into these high pass, what these high pass band and stop filters mean, because as I got to know from my batchmates, you have studied this earlier on, and I discussed this in the class, and but I won't do them again. If you really want some help, you can refer to the lecture slides from your previous modules. And, you can look up these videos on YouTube on your own. That's kind of a punishment for not being in the class. Not exactly a punishment, but I won't discuss things which have been, I won't rediscuss things which have already been discussed in previous modules. I'll discuss them once in the physical class, but in the lecture recordings, I won't rediscuss things. So please be present in the class. So if you are present in the class, then you won't have to spend additional time on recalling these things. I just recall them for you within the class, and if you have any questions at the time, you can just ask me within it. Right. Well, that's some incentive for you to be present in the class, and let's move on from that. Okay, then. Our objective is to predict the behavior of this simple passive low pass first order passive low pass filter using mathematics alone and with the help of no other software or tool. And this can be done through obtaining a expression called the transfer function, finally evaluating obtaining an expression for the gain and evaluating it. Right. Now, this module and this lecture in particular does not focus on obtaining transfer functions in general. So I'll just give you the steps which you can follow to obtain a transfer function for this particular case of a low pass filter of the first order. And I went through the whole steps and sub steps in detail and I wrote them down within the class. I'm not going to do that over here once again. So your batchmates who were present in the class have written down what I wrote on the whiteboard. And since I don't quite have an alternative for the whiteboard on my laptop, I won't redo those things. So I suggest that you obtain the notes that your batchmates have written down and share them amongst yourself. And, I'll just give you an overview of what to do with regards to the steps. So step one is to write down expressions for the impedance of the passive elements, resistor and capacitor. So they can be written down in this manner. And once again, the scope of my lecture is not to remind you how to write down these impedances. If you don't remember, please look them up from your previous lecture materials or videos on YouTube or articles on the internet, and recall these things since these aren't whether you move into higher studies or the industry, you'll regularly see these things pop up regardless of what kind of application that you're dealing with. Okay, then once you have written down the expressions for these impedances, then you can solve for the output voltage. And how do you do that? Upon some careful observation, you must be able to see a voltage divider within this whole circuit. So the circuit consists of two passive elements connected in series.